Hello, in this session we are going to talk about the sine rule and the cosine rule. So these two rules allow us to make use of sines and cosines to find the sides and the angles of a triangle if we know some one or two of the sides or angles. Right? So the rules will allow us to find all the other sides and angles. So before we describe the rules, we need to look at a simple way to describe a triangle. So that's a triangle. Now a common way to describe the triangle is to label the corners with capital letters. For example, ABC. It doesn't have to be ABC, it can be BCD or PQR or XYZ or just any three capital letters. So the way then to describe the sides of the triangle is to use a small letter for the side opposite to the corner. So for example, if this corner is A, we use a small letter of A for the opposite side, small letter B for this side, and small c for this side. So this makes things more convenient because if we talk about a big C and a small c, we know that we're talking about the angle and the side opposite. So now that we have described these notations, we can start on the sine rule. So first, let me write down the sine rule. And the sine rule is a set of formula relating the angles in the side, and it goes like this. Sine of the angle A of this angle divided by the opposite side, little a. Right, we have a fraction there. This is equal to the sine of another angle B, this one, divided by its opposite side, B, and this is also equal to sine of the remaining angle C divided by its opposite side. So just a very simple rule. If you're seeing this for the first time, it might look quite strange. You might ask, why is it like that? Why is this equal to that? We can understand this formula quite easily for the case of sine rule. Now let's try and understand the first part. Why is this equal to that? We can do that by drawing a perpendicular in a triangle. Alright, now let me call this length h. Now we know that h is related to the side B and the angle A because h and B forms a right-angled triangle. Alright, so sine of the angle A is actually equal to h over b, because h is the opposite to A and b is the hypotenuse for this right angled triangle. Alright. Now, look at this other right angled triangle with the sides A and H and the corner B. So this is a right angled triangle as well. And if I think about the sine of the angle B, that would be H, the opposite, divided by A, the hypotenuse. So H over A. Alright. Now let me rearrange those two. Okay. Let me bring the B over to the other side. Get B sine A equals to H. Likewise, if I bring A to the other side, meaning multiply both sides by A sine A is equal to H. So B sine A and A sine, that should be B. And A sine B are both equal to H, meaning that those two are equal. Okay. Running short of space here. So if I now write down these two expressions in an equation, I can say sine B times sine A is equal to A times sine B. Then if I divide both sides of this by AB, let me now drop the H there. If I divide both sides of this by AB, you see that the B here cancels and the A there cancels, and you end up with that equation. So this is how the sine rule comes about. It's fairly easy to understand why. So now that we have a good idea what the sine rule is about, let's have a look at an example of how we might use this formula. So suppose we have this question. Solve this triangle. We are given a triangle in which two of the angles are 70 and 40 degrees, and one side is 6 centimeters. And the question is to solve this triangle. Now, what exactly does this mean, to solve the triangle? What it means is simply that you must find all the sides and angles in a triangle. Now in this case, it means that we must find this angle, this side, and this side. So that is the question, right? Given this triangle, find all the other angles and sides. Right, so let's start by giving the corners a letter. Let me call this A, B, and C. So this side would then be A. A is 60 degrees. This side would be B, and this side is C. The easiest thing to do first is to find that angle, because we know that the sum of angles in a triangle is 180 degrees. So the angle A must therefore be 180 minus 70 minus 40. That's 70 degrees. Right. So actually, we now know that this is 70 degrees. And it turns out to be a very simple example in which these two angles are equal, so therefore those two sides are equal. And then we can find the third side. But I really want to find an example, to show an example in which all three sides are different. So let me choose a slightly different angle. Let me choose 60 degrees for that. So let's start again. So suppose that that's 60 degrees. Okay. 60 degrees. Then to find the angle A, we would have 180 minus 40 minus 60, and the answer is 80 degrees. Right, so now we have 80 degrees here. Okay, that's a better example. So now we have one angle. Now the next step would be to try and find the two sides B and C. So here's where we can use the sine rule. Alright, now if you recall, in the sine rule, each of these requires us to know an angle and the opposite side. In this case, we know this side, we know the opposite angle. Okay, so let me try and write that down. If I simply substitute these two numbers into the formula, sine A is sine 80 degrees, side A is 6. What about sine B over B? Angle B is 40 degrees, so that's sine 40 degrees. Side B is unknown. Now we have an equation. We have an equation here with one unknown, B. Sine 80 and sine 40 degrees we can find using our calculator. So therefore, we can solve for B. So let's try that. Now there are two ways we can work this out. One way is to take out your calculator, calculate the values of sine 80 and sine 40 degrees, write them down, and then do the algebra to find B. However, if you do that, you'll find that you could have some rounding off errors. And rounding off errors means that when you go to your calculator, press your calculator to find, for example, sine 80 degrees, you would normally get a number with many decimal places. And to write down the answer, you would just give a few places, maybe 3 or 4 significant figures. If you do that, you chop off many of the other decimal places. And if you do that again there, you chop off more decimal places for the sine 40 degrees. And then when you finally rearrange and solve for b, you chop off some more decimal places. So chopping off the decimal places is chopping off some of the accuracy. And that's what we mean by rounding off error, because if you chop off some of the decimal places, that makes the answer slightly wrong. But we can't help it because we can't write all decimal places. But we want to try to reduce this rounding off error as far as possible. So what I would prefer to do is to do the algebra with the sine 80 and sine 40 first. Now let's see what I mean by that. Now what I would do is I would multiply both sides by b. If I do that, b comes over there. Okay. I would multiply both sides by 6. So 6 goes over there. I still have the sine 40 degrees. And then I divide both sides by sine 80. Sine 80 degrees. Yeah, so I would do the rearranging. I would do the algebra with the sine 40 and sine 80 so as to get everything on one side and b on the other side. So now I have solved for b. Alright, I've got an answer for b in this form. And if I now want to find an answer, I would then take out my calculator and press in the numbers and get the number directly without having to calculate sine 80 and sine 40 separately. So let me try and do that now. I have my calculator here. Switch that on. Right, see if you can see that. I have a 6. You see that? Just about, right? I have a 6 times sine 40 sine 40 close bracket divided by sine 80 equal 3.916. Four significant figures is what I normally prefer to put down, and that's B. So this is 3.916 centimeters. Alright, so we've got that side. Now we have one more side to find. That's the C there. Let me clear this. So now that we have some experience in finding this, we know that we can go on to make use of the same sine rule, probably. So let's try that. Sine A over sine little a would be sine 80 degrees. Then divide by 6. Now this time I want to make use of the C. So sine C, the angle C is 60 degrees. Little c is unknown. That's what we want to find. So I have another equation here. Looks pretty much the same as the previous one. So this is how I would do it. I'll bring C over there by multiplying both sides by C. Multiply both sides by the 6. Sine 60 degrees. Alright. This will be over sine 80 degrees, which I get by dividing both sides by 80, sine 80. So once again, okay, let's take out our calculator and do it again. So that would be 6 times sine 60 divided by sine 80. Correct? And the answer is 5.276. Right. There we are. 5.276 centimeters. And now you see that I have found all 3 angles and all 3 sides of the triangle. I have solved this triangle. That's how we answer this question. Alright, the next rule we are going to look at is the cosine rule. Alright, again we have a triangle. We describe it by calling the corners ABC, capital letters, and the opposite sides ABC with small letters. Now the cosine rule looks like this. It goes A squared is equal to b squared plus c squared minus 2bc cosine A. Now this is a bit more complicated than the sine rule. Right, there are squares involved and there are a few terms multiplied together. Takes some getting used to. Now let's have a look at what this is trying to do. Let's start with the cosine A. Now, the cosine A is this angle. And on the right side we have this angle, and we have the 2 sides B and C. We have this and this. So we might imagine that, suppose you have a question in which you are given 2 sides B and C. Alright, you're given the values of those 2 sides, and you're also given the value of the angle in between the 2 sides. If you have such a situation, then you can use this formula to find the remaining side. So, and that's exactly how we could use the cosine rule. But of course, we know algebra, and that means that, for example, there's another way we can use the cosine rule. If instead we are given all 3 sides, but we don't know the angle, That means that we are given A, B and C, but we don't know the angle A. Then we can use algebra to solve for cosine A, and then use a calculator to find the angle A. So that's how it works. Now in this case, I'm not going to explain the reason behind this formula. It's a bit more complicated. What I'm going to do is to go directly to show you one or two examples of how to use the cosine rule. Right? Suppose I have a triangle. Okay, let me clean this up to make some space. So the cosine rule is a squared equals to b squared plus c squared minus 2bc cosine a. Suppose I have given the triangle 4 cm, 7 cm, and an angle that is 60 degrees. So the question here is again to solve this triangle. So once again, the question is to find all the sides and the angles of this triangle given these two sides and given this angle here. So we have a choice. We have seen that just now that we could actually use the sine rule to solve a triangle. Now, and by comparing the sine rule with this formula, you can see that the sine rule is obviously simpler. It doesn't have, at least it doesn't have the square, and it doesn't have so many terms in the equation. So if possible, the first step will be to try using the sine rule and see whether it is possible. Now, but in this case, you'll find that it is not possible to use the sine rule, because in order to use the sine rule, you have to know a side of the triangle and an angle opposite that side. So for example, if I know 7 centimeter for one side of the triangle, I must also know the opposite angle before I can use the sine rule. Alright, in this case I don't know the angle. Now that's 4 centimeters. I don't know the angle opposite the 4 centimeters either. Okay, and that's 60 degrees, and I don't know the side opposite the 60 degrees. So it is not possible to use the sine rule, because the sine rule always goes sine A over A is equal to sine B over B and so on. So you must always know the pair of side and the opposite angle before you can use the sine rule. And in this case you can't. In this case we have a situation where instead we can only use the cosine rule because we know two sides and we know the angle in between, which is exactly the way I have described the right hand side just now, right? With BC are the two sides and A is the angle in between. So I have these two sides and I have an angle in between. So this is how we can think of the way to solve the problem. We try something simple first, like the sine rule. It doesn't work. we go on and try the cosine rule. So in this case, we should most likely use the cosine rule. So that's the first step to think about. Now the next thing we want to think about is to label the corners and the sides. Now there's a little trick in doing this, because if you look at this formula, we want to try and apply this formula, and you have the sides A, B and C. So which of these sides should we call A, which one should we call B, and which one C? Now the idea is that you want to use the letter to make it easier for you to use the formula. So in this case, we know two sides and an angle. And in the formula for the cosine rule, that angle is A. So why not call that angle A? So this will make it easier for us to use the formula, because the formula is going to work for any angle, or as long as we know what the angles and the sides are. So if I call that side A, then call that angle A, then those other angles will just be B and C. Okay, so and the 4 cm would be the B, 7 cm would be the C. Now it really does not matter whether I call that B or call that C, because if I exchange B and C, the formula is still the same. B squared plus C squared is the same as C squared plus B squared. Right, so now that we have given names to letters to the sides and the angles, we can now substitute the numbers into the cosine rule. So let's do that. That's the A. So A squared is equal to, B is 4 centimeters, so 4 squared plus C is 7. 7 squared minus 2 times BC, so times 4 times 7. Cosine A is 60 degrees. So at this step, you might want to take out your calculator and calculate the whole lot to get the answer. I'm just going to do some very quick calculation mentally to make things easy. You can try that if you like mental sums. So 4 squared is 16, 7 squared is 49, minus cosine 60 degrees, if you remember, is equal to half. So that and that cancels. 4 times 7 is 28. Right, so I'm going to take out my calculator now. We'll calculate that. 16 plus 49 minus 28, that's 37. So therefore A is the square root of 37. .083. There. So now we have side A. A is 6.083 centimeters. All right. Now we have all three sides and we know one of the angles. All right. The next thing to do would be to find those other two angles. Now since we now have one side and we know this combination of one side and one angle, this means that we can now use the sine rule to find the other two angles, and you would follow exactly the same method as before, as the example just now where I described the sine rule. So I shall not go into the remaining calculations. You can try it out for yourself. But what I'm going to do instead is to show you an example in which you are given the sides of the triangle and you have to find one of the angles. Now to make it easier to do this next example, I'm going to rearrange this formula and make cosine A the subject. Now, so if you work on this algebra and do some rearranging, you will find that cosine A is equal to b squared plus c squared minus a squared over 2bc. Alright, so what this means is that in this formula, if you know all the sides of the triangle A, B and C, you can use this formula to find one of the angles. Which one? Well, the one opposite the letter A there, where you do the subtracting. So let's look at an example to see how this might work. So suppose this is 6 centimeters, this is 5 centimeters, and that's 7 centimeters. And suppose that the question is to find this angle. Find the angle x. So how would we do that? If I'm going to make use of this formula, I can think of the x as the angle A. So let me call this side A. Now I can call the other side, either of the other side B and C. Okay, so this side will be letter A, letter C, that's letter B. So now that I've labeled all the sides, I'm ready to use this formula. Now A is the x, so this is cosine x. B, 6 centimeters. C, 7. A is 5. Divided by 2bc. B and C, 6 and 7. So 2 times 6 times 7. Okay. Let me just do a quick calculation before using the calculator. 6 squared is 36. 7 squared 49, 5 squared 25. Right, 2 times 6 is 12. 12 times 7 is, let's see, 84. Alright, let's use the calculator. Okay, right, so this is how I would do it. 36 plus 49 minus 25. Start a bracket. 36, okay, plus 49 minus 25 divided by 84. Five over 7. Okay, if I press that, I'll get it in decimal, but that's not really necessary. Let me write this down as 5 over 7. Alright, if I then want to find x, now if you remember how to find the angle, you write down inverse cosine, the minus 1 there, of 5 over 7. Remember that the inverse here does not mean 1 over cosine. It just means that if you know the cosine, you need to find the angle. Right? So this is the symbol that tells you that you want to find the angle. We call that an inverse cosine. So 5 over 7 there. Let's try that. So we need to do, right, the inverse cosine is shown by this little, if you look at the cosine button, just above the cosine button, you'll see some tiny letter that says COS with a minus 1 next to it. That's the inverse cosine. And we can use that function by first pressing the shift button followed by the cosine button. Right, that gives us the cosine minus 1 symbol. Okay, and we know that the cosine is 5 over 7, so 5 divide 7, or you can do 5 over 7 as a fraction, close bracket, and that's it, equal 44.42 degrees. There, that's the answer. 44.42 degrees is the angle x. Okay, we'll finish here for this session. See you next time.